Hi all. Today we will discuss about multiprocessor organization. This is a very important topic. As all of you know, multiprocessor is nothing but there are two possibilities. Either multiprocessing, that means having multiple processors, in single computer, single digital computer. This is one possibility. So the diagram looks like if this is my computer, it can have n number of processors, can all are connected to shared memory and connected to IO devices. So let me redraw the diagram. If this is my memory, then these are the processors which are connected: P1, P2, P3 and P4. These are the processing units that are connected to a computer shared memory, and these are the IO interfaces: IO interface 1, IO interface 3. So there exists a network which is connected to memory. So this is an idea. Let me redraw the picture to have a better understanding. See, this is my network and these are my processors: P1, processing units, you can call it as PU1, PU2, PU3 and PU4, which are connected, and this is my shared memory, and of course these are the IO devices: IO interface 1, IO interface 2, IO interface 3. So this is how a multiple processor computer, processing units, a standalone computer with multi-processing units it can contain. So first you should have an idea that the multiprocessor means two possibilities. One, or I can call it as parallel processing. The parallel processing can be achieved by two ways. Single computer, one possibility is single computer with multiple processors, or a network of computers. So let me redraw the picture. This parallel processing means single computer having multiple processor or a group of computers. The parallel processing can be achieved by these two ways. And how multiprocessors are organized? There is a famous Flynn's taxonomy. Flynn's classification, or Flynn's taxonomy, which divides how multiple processors are organized in a computer. The first one is SISD, single instruction and single data stream. So the single instruction and single data stream is a technique which is very much similar to sequential processing or sequential computing. So in sequential computing, what happens? The single instruction is taken by a control unit which will decode and send to ALU. The ALU is also called processing unit, which gets single data from memory. So the diagram looks like single control unit sends ALU, contains only one processor. What it contains? It sends single instruction, that is called SI, and it also receives from memory, that is single data. So for that reason it is called SISD. So this is the very basic model. It's nothing but a one human architecture where we have single instructions and single data. Here processing unit is a single processing unit, takes the single instruction from control unit and operates on the single data. So this is called in Flynn's taxonomy or in Flynn's classification architecture, this is called single instruction, single data stream, that is SISD. Now, so let us read. This is a single instruction, single data stream which contains single processor. As I said, it contains single processor, that is ALU, or we can call it as a, rather than ALU, we better call it PU. The reason is ALU doesn't contain internal cache, but PU means it contains three things. One is internal cache and special registers. Internal cache is called L1 cache. So processing unit and ALU. So a processing unit, if somebody says processing unit, you should understand it contains three things. One is ALU and cache, internal cache and registers. So it is a combination of these three. For that reason we are call it as processing unit. So it is very important to understand, have an idea, because in this thing we will be discussing frequently what is meant by processing unit. So remember, processing unit is something like which contains ALU, that is arithmetic and logic unit, cache, moreover it is called L1 cache, that is internal cache, and some register, special purpose register. The combination of these three we call it as processing unit. And processing unit receives the instructions from control unit, that is single instruction, and it receives single data from memory. So this is the diagram of a single instruction, single data stream. So here new point is that processing unit. Processing unit is nothing but it is ALU, cache and registers. It contains a single processor, Single instruction stream, the control unit sends single instruction, data stored in single memory, so the memory sends single data, and it's a uniprocessor. There is only one processor, there is one ALU. Rather than ALU, we are referring it as single processing unit. This is about SISD. So this is the picture what we are discussing so far. Here control unit sends single instruction to processing unit. Similarly, memory also sends single data stream to processing unit. Remember, processing unit means it is a combination of ALU, cache and register. It is a combination of these three: ALU, internal cache and registers. So this is a very important concept, the basic concept, the basic type of classification according to Flynn's. See, we are discussing about multi-processor organization. So we are interested in processing units having more than one. There is more than one processing unit. Next, we have the another type, that is SIMD, single instruction multiple data stream. First, let us try to understand what is meant by single instruction. With the understanding of SISD, one can easily guess that the first SI refers to single instruction. That means the control unit sends single instruction to processing unit, but it receives multiple data from memory. It is quite interesting one, receiving multiple data. What might be the example? The best example is array. See, if it is SISD, let's assume I am taking example of a C language. I hope you know C language, otherwise no problem. Just this is a array is nothing but a group of homogeneous elements. So let me declare an array in a C programming language. This is, so I declared an array, that is group of elements. There are 10 elements exist in the array. What are they? A of 0, A of 1, A of 2, A of 3, A of 4, A of 5, A of 6, A of 7, A of 8 and A of 9. Total 10 elements. If you want, you can refer 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 elements. So I am declaring an array. Now I want to assign values into, I want to store the values in this array. In case of SISD, single instruction, single data, since I can access only one array element at a time, I have to use for loop. For, since this is a C language, I should declare int I is equals to 0, int I is equals to 0, I less than n, I plus plus. What is n here? One can easily guess that n is nothing but 10. And assign A of I is equals to simple I. So here what's happening? In case of SISD computer, this is the code, right? Because if the memory contains, and the specialty of this array is that the elements are stored in a contiguous memory location, A of 0, A of 1, A of 2 up to A of 9. So A of I assigning the, if you see the statement, A of I is equals to I in the for loop. So this is called a single instruction, and this is called, and it requires a single data. This is the single data, and this is a single instruction. This is single data, right? The ALU simply assigns the value of A of 0 to 0. Like that it go on repeats until for loop. This usual thing happens in SISD. But what happens, the same case in SIMD, single instruction and multiple data. What happens here means, so in case of single instructions and single data, we have seen, in case of single instruction and multiple data, instruction is a single, that is A of I. What is the instruction? So SIMD, right? A of I is equals to I is a single instruction. But for this, what is the multiple data? We have MD, multiple data. So it should work on A of 0 to A of 9. Single instruction should work on multiple data. So array is a best example for accessing multiple data elements at same time. See, even array elements, but the point is you can perform this, or you can execute this instruction by processing unit, or you can perform any operation only on single array element. This is called single array element in array. You can't perform this operation on entire array at once. You have to use a for loop. For that reason we are using a for loop, by accessing a single element, single array element from A of 0 to A of 9. I hope you are getting point. So if it is a SIMD computer, see in the lab, in your computer lab, in your college or in an institute, you will write, if your tutor or instructor asks you, write a program to assign some elements, some values to the array elements in an array, definitely you would use for loop, because all those computers are uniprocessor computers or single processor computers. But there are some computers which are equipped with SIMD processors, single processor, single instruction, multiple data stream. First you should understand the need for having SIMD. So what SIMD, the advantage of SIMD is that the programmer or developer can perform a single operation on entire array. This is most important. So SIMD computer means, SIMD computer means perform single instruction on multiple data stream at same time, that is an entire array. So this is the concept behind single instructions and multiple data. How it is achieved, let us try to understand. So here we have a single instruction, single machine instruction. Yes, of course it is a single machine instruction. Controls simultaneous execution. See here, simultaneously you have to execute on the entire array. We have number of processing elements. This is important. So we have more than one processing element, unlike SISD where we have only one processor, one unit processor. Here we have number of processing elements. Then lockstep basis, we'll try to understand what is lockstep. Each processing element is has associated data memory. Each instruction executed on different set of data by different processors. So same instruction is executed on different set of data, different array elements by different processor. This is called vector and array processor. This is most important thing. So the SIMD computer is also called vector and array processor. If somebody asks what is vector processing, or vector processor means simply you can give one line answer. Performing a single instruction or single operation on entire array using single instruction. That is nothing but vector processing. So there are some vector processor or array processor. We will see all those details. Now let's try to understand the picture or image of this how SIMD computer would be. So as you might have seen in the picture, in the diagram, we have one control unit, one instruction. So this is a single instruction, this is a single instruction, and so we have a number of processing elements. Unlike SISD where we have only one processing unit, we are calling it as a processing unit or processing elements. The two are synonyms, they can be used interchangeably. So the processing elements, we have n number of processing elements, and this is a of 0, the data string, multiple data stream up to a of 9. So these are coming from different memory locations. LM stands for different kinds of memory locations. But you may get a doubt, sir, what happens if I declare 10 array? Should I need to have 10 processing elements? What if the array contains 100 elements? Do you really need 100 processing elements? No. Set of processing elements are fixed. They might be 5 or 10. They work on repeatedly on multiple data stream. So the goal is to reduce the computational time. So this is the concept behind the SIMD computer, and it's very important. Most of the processors in research related organizations prefer to use this vector and array processors. And see, the instructions are also different. It's not like normal instructions. The instructions are also different. They are complex instructions. We will see there are some when we discuss about the processor types. There are CISC processor, RISC processor. With single instruction, you should work on entire array without using for loop. So if your computer is equipped with vector processor, array processor, you can access all entire array or entire array elements with a single instruction, means without using for loop. So that is the capability of SIMD processor, and it's very popular processor. Remember, most of the research organizations like Defense or DRDO or ISRO, they prefer to use these vector processors or array processors, or you can call it as SIMD, single instruction and multiple data stream processors, because in research what happens very frequently, you need to work on entire vector is nothing but just like an array group of elements. So they are very popular in research area, SIMD. Next we see, uh, although much not popular, but still it has some significance, that is multiple instructions on single data, MISD. So in MISD what happens, how you can get that, as it's saying multiple instructions, if this is my control unit, so it's like this is my control unit, there are multiple control units, CU2, let's take CU3, and which sends multiple instructions, instruction 1, instruction 2, instruction 3, and this is my processing element 1, processing element 2, and processing element 3, and multiple instructions on single data. So the memory sends single data to processing element 1. So this instruction 1 is operated on single data. Next what happens, the output of this instruction 1 is sent as a input for next instruction 2. So, and next instruction 3, for the instruction 3 the output of instruction 2, like that. So the result, ultimate result is sent back to memory. I hope you are getting how multiple instructions on single data stream works. So here what happens, sequence of data transmitted to set of processors, just now we have seen. Each processor executes different instruction sequence, never been implemented. So here what happens, there is no consistency, data consistency is against to data consistency, but still the SI multiple instructions and single data stream is used in some application areas, but it is not very much useful. So here let me redraw the picture. Here I have control unit 1, control unit 2, control unit 3. Let's assume I have 3 boxes: control unit 1, control unit 2, and control unit 3. And I have 3 processing elements: processing element 1, processing element 1, processing element 2, processing element 3. And I have a memory. So the single data is coming from memory, and the control unit sends instruction 1, control unit sends instruction 2, and this sends instruction 3. So initially processing element 1 receives single data from memory. So it goes like this. Then instruction 1 is executed on the data when it modifies, and the output of this result is sent to as an input to for instruction 2. So similarly, the output of instruction 2 is sent as an input for instruction 3. Finally, the results are sent back to memory. So this is how the multiple instructions and single data works. Next, another popular one is that very popular one is multiple instructions and multiple data stream. So multiple instructions and multiple data. So you might have understood that if I have a multiple instructions, I have number of control units, more than one control unit, and more than one processing elements. Since this is multiple, the memory is divided into multiple memory units. So everything is multiple here. Control unit or processing unit, processing elements, and memory elements. So they send multiple data 1, data 2, data 3, and they send multiple instructions I1, I2, I3. So it's just like multiple processors having individual multiprocessors, and the thing is they don't share a common memory as in SIMD. Remember, in SIMD processing elements share single memory, but here the memory is also divided. So how it contains, try to understand. Here we have a set of processors, yes, simultaneously execute different instructions, not same instruction, different instruction sequences on different set of data. So in SIMD, same instruction on different set of data, but in MIMD it's an advanced, we can call it as MIMD as an advanced version of SIMD. So in SIMD, same instruction getting executed on multiple data, but in case of MIMD, multiple instructions or different instructions executed by different processors on different set of data. So SMPS, so multiple processors, symmetric multiprocessors, clusters, NUMA systems, these are the examples of multiple instructions and multiple data stream, which is again a most popular one. We'll see the example here. So what happening? I have a number of control unit 1, 2, control unit n. Each sends different instruction 1, instruction 2, up to instruction n, and there are multiple processing elements E1, E2, and data is coming from shared memory, but this shared memory is divided. So this is called MIMD, that is multiple instructions and multiple data. So this is how it works. So there are different versions of MIMD, like MIMD in distributed memory. Here, as I said earlier, memory can also be divided into number of memory locations. See here, this is control unit, n control unit, each one decoding a separate set of instruction, and which is sent to each processing elements. But here what's happening, this is memory, total memory, but here memory is a distributed memory. So what is meant by a distributed memory? Distributed memory in the sense memory is being divided into different memory locations or memory parts. Memory is also divided here. See here, this is one set of memory location, memory location up to LMN. So it's LM stands for, you can call it as local memory. Local memory for processing element 1. So the importance of this local memory compared to shared memory is that only processing element 1 have access to local memory 1. The PE2 can't access local memory 1. Each processing element having its own local memory. So these memories are connected by interconnection network. So because if processing element 2 wants to access element, they can go by interconnection, but not directly. So this is implementation of MIMD using distributed memory. Here memory is divided into some local memories for each processor. So we see the taxonomy of parallel processing. We'll see overall view how processor is organized. See, processor is organized. This is called single instruction, single data stream. This is called uniprocessor. And single instruction, multiple data stream. Remember how it was single instruction? There is only one control unit, one processing element, but the data is on like array, vector data. So this SIMD can be implemented by using vector processors and array processor. We will see what is meant by vector processor and array processor. And third one, very seldom that it is implemented in real world, where it is called MISD, that is multiple instructions and single data. And the last one is very popular one, that is multiple instructions on multiple data stream. And this can be implemented by using shared memory. This is called tightly coupled. So tightly coupled means all the processors have to use the same memory, same address system bus to access the shared memory, which is called tightly coupled. So remember this word. If you see somewhere else tightly coupled means it is related to memory, that processors, there are multiple processors being, or there is a one common memory being shared by multiple processors, which is called tightly coupled. And as we seen, there is also another type, that is distributed memory, which is called loosely coupled, because each processing element has its own memory, local memory, which is called clusters. How it can be implemented using clustered. This is called loosely coupled. It's very important. Tightly coupled and loosely coupled. Tightly coupled means all the processors sharing a common one main memory. And distributed memory means loosely coupled. That means each processor has its own local memory, and all these memories are of course interconnected. This is called loosely coupled. So again, into the tightly coupled, we have again two types. One is symmetric multiprocessor And in symmetric multiprocessor means each processor is treated as an equal. Each processor has the equal right to access main memory. There is no priority among the processors. This is called symmetric. So it's very important to understand this one, the word. So symmetric multiprocessor. Symmetric means each processor should have equal right to access memory. There is no priority among the processors. And against opposite to this is called NUMA, non-uniform memory. So NUMA stands for non-uniform memory access. Non-uniform memory access, or it is called NUMA. So in NUMA what happens? Processor has the priorities. One is called master processor, another is called, there is one processor which is declared as a master processor, and there are some slave processors. So what happens, this master processor has the control over the shared memory. It can issue the memory. So all the slave processor has to request the master processor for gaining access to memory, system bus and memory. This is called NUMA, non-uniform memory access. So we'll see an overview of MIMD. MIMD contains general purpose processors, and each can process all instructions necessary. Yes, each processor can have its own set of instruction space, further classified by method of processor communication. I said it is the shared memory, then it is called tightly coupled. If each processor has its own memory element, local memory, which is called loosely coupled. In shared or in tightly coupled also we have symmetric multiprocessor. All the processor has the equal right to access the shared memory. Another one is there is a priority among the processor. One is declared as a leader, which is called master, and the remaining are called slave processor. And they say the slave processor wants to have an access to the system bus and shared memory, they have to request the master. This is called non-uniform memory access, NUMA. So this is an overview of Flynn's classification of Flynn's taxonomy or Flynn's classification. Now we move on to another important topic, which is called pipeline processing. So what is the importance of this pipeline processing means? First we try to understand what is meant by a pipeline. So pipeline is like, you might have seen in many industries or many companies, let's assume some chocolate manufacturing company, and let's assume its task is being divided into 4 parts: task 1, task 2, task 3 and task 4. Task 1 is preparing the chocolate, the material. Second one, making into a specific shape. Third one, wrapping around some cover and placing in some basket. So these are the 4 tasks in chocolate manufacturing company. So what happens when material comes over to uh, task 1 phase? So this material, some material, let's assume 1 kg material sent to task 1, then it prepares, mixes all the materials and sends to S. When it sends when T1 sends this task to T2, T1 can't sit idle. Again you send 1 kg of memory. So it prepares, it mixes. So when T1 is doing some mix, T2 is also doing shaping. Once T2 completes shaping, it handovers this thing to T3, where T3 performs wraps. When T3 is performing wraps, can you guess what T1 and T2 might be doing? Yes, T1 is getting another material of 1 kg, so it's doing mixing, and T2 is doing shaping of the material which already mixed by T1. So once this T3 wraps around, it sends to T4. It's a bag. It's some package. Put some in a bag or basket. So tell me, when T4 is doing something on the basket, what T3 is doing? T3 is preparing a wrap around for the chocolates to send to T4. What T2 is doing? T2 is doing cutting different shapes of chocolates. What T1 is doing? T1 is doing mixing of the materials. So simultaneously processing, as if the T1, T2, T3, T4, if there are some machines or some persons, they won't be sit idle. See, T2 will not sit idle until T1 gets. T2 has its own work. So this concept is called pipeline processing, that we'll discuss in the next video.